Hello and welcome to this video on damping in simple harmonic motion. So we're going to look at what damping is and the different types of damping and their effects. So damping is a reduction in the amplitude of an oscillation as a result of energy being drained from the system to overcome frictional or other resistive forces. It's basically what stops something from oscillating forever. It's that loss of kinetic and potential energy. Let's have a look at that in a practical.
So what I've got here, I've got a motion sensor linked up to a data logger, and I'm hoping it will, we can get a clear image. Mass on a spring behind it. Okay, so we're going to start by looking at the normal oscillations of the mass on a spring. So if I start the data logger going and displace this, now the sound you can hear is the motion sensor, which is sending a sound pulse. It's reflecting off of the masses, and then the reflection's being detected so it can work out the distance. Right, so if we have a look at the graph we've drawn there, we can see that those oscillations stay pretty much at a constant amplitude. That's because there's very little damping on the mass as it stands. Now, if I add one of these squares of card to the bottom of the mass, what I'm going to do is increase the air resistance as it goes. So if I start to displace that and then get that started again, and if we look at the results, you can see that that blue line is reducing in amplitude much quicker than the red line was, which shows the increased damping, so the energy loss in each oscillation. Okay, so this isn't going to be heavy damping. This is going to be light damping, but much more significant damping than we've seen previously because we've got much higher air resistance. So again, I'm going to start that off. And you can also see that that card is rubbing up against the clamp stand, creating more friction. So if we have a look at the result, this time we're looking at the green line, and you can see that over the course of that trace there is a significant decrease in the amplitude of oscillation. That is damping.
Okay, so what we saw in that video was light damping, and in light damping the amplitude decreases by a small amount over time. So each oscillation they lose some of the amplitude. And that's the blue line on this graph. In heavy damping you don't get any full oscillation, so you're always going from the highest possible amplitude to zero without it oscillating at all, and that's shown by the green line on here. So the blue line is our light damping, the green line is our heavy damping. Now, I don't think that the red line on here is a very good actual representation of critical damping, because in critical damping it should only make one oscillation before returning to the equilibrium position. So if we have a look at that with the line I'm drawing on the graph, you see that it goes from its maximum amplitude, the period doesn't change, one oscillation, and then the amplitude remains zero. That's what we would call critical damping. Okay, so have a go at some past exam questions. Drop me an email if you have any problems.